sum theory, part 2. This is an extension of the previous minimum sum theory with some extensions applied to some progressions like arithmetic progression. Arithmetic progression with positive definitely elements. A simple example here, let us assume that we have got a general n-term arithmetic series in the following shape. A, then the second term is a plus d, and a plus 2d is the third term, and so on to the last term, a plus n minus 1 the whole then times d. This is a very well known progression in which we already know in basics of mathematics. Definitely here, a and d, a is the first term and d is the common difference, are positives. Now the question is, what is the expression for the sum or the minimum sum? The same theory as we introduced it in our last presentation. Now the analysis or the solution here can be in the following way. It's fairly very simple. Definitely, if you can remember from the algorithm in which we introduced in our last presentation, the first step is to rewrite the expression or the series or the sequence of the numbers in descending order from the largest to the smallest. So it means simply here we just reverse writing this arithmetic progression from backwards. A plus n minus 1d is the largest one, then the next until to the least one, which is the first term in the original one, in which here becomes the last term. This is simply like x1, x2, x3 to xn. x1 is the first term, x2 is the second term, and xn is the nth term. The same as we introduced. Now the algorithm. Applying the algorithm here is simply, after rewriting in descending order, the first term take away the second term, in which simply if you do this calculation, a plus n minus 1 times d, then a plus n minus 2 times d, then this becomes equal to d. D here is the common difference. The next step here is x3 minus this d. If you simplify, then you will get a plus n minus 4d. This is the fourth term. These calculations are fairly very simple, and then you can do it easily and check. The next one becomes 0, certainly here. The next one, following the same steps as we introduced, becomes the fifth term, and the next one becomes d again, and the next one becomes the eighth term, and so on. No need for writing all of them. So now probably from here we can get to a pattern of the solution, in which we call it the general solution here in this conclusion. So what is this conclusion? Now we realize from here, if the number of terms n of the arithmetic series is multiple of 4, like n is equal to 4m, m is equal to 1, 2, 3, and so on, all positive integers, then the minimum sum is equal to 0, regardless of a or d or the number of elements, as far as it's multiple of 4. The second conclusion here, if the number of terms of the arithmetic series is 2, 6, 10, 14, and so on, in which the general expression can be n equals 2 plus 4m, m is equal to 1, 2, 3, and so on, again is positive, then the minimum sum is equal to d, the common difference, regardless again here of the size of the data, as far as is equal to 2 plus 4m, or the initial or the first term. Then definitely otherwise n is odd. So it means the third possibility here, if n is odd, then here we split into two categories or two sets. One of them is if n, the odd, is equal to 3 plus 4m, then the minimum sum will be given by this expression depending on m, depending on a, depending on d, in contrast to the above. The second possibility here, if the odd, or if n is odd equals 5 plus 4m, then the minimum sum will be equal to that expression. So all of those we concluded it from our previous calculation and analysis. Now the general form. So we can represent the general form in the structure here. The minimum sum equals 0 if n is equal to 4m, multiple of 4, equals d if n is equal to 2 plus 4m, equals a minus 3 plus 4m times d if n is equal to 3 plus 4m, and so on. The last two is for the odd. Here m is equal to 0, 1, 2, 3. The next step is we have two results. These two results are quite interesting. If, for example, let us say we assume that x is an arithmetic series like the following: a minus d, a minus 2d. Here, just for simplicity, I'm writing it in the upside down, okay, so that it will become like a descending order. It doesn't alter the solution. And the s minimum, we define it as s, and then assume that this x is shifted by a positive number, which is gamma. Then x dash is equal to x plus gamma. Any element here, every element is added by gamma, shifted by a positive number. This minimum sum dash, this is the new shifted data here, is equal to s dash. Then simply we can introduce, or we can easily prove through the same process as we did before, in which I leave it for the reader to verify that. S dash is equal to 0 if n is equal to 4m is equal to d, the same d as the original common difference, and the last one here is for both possibilities of n is odd, in which s dash is shifted by the same amount as the original data by gamma. The second result is multiplication. So it means again here, if x is assumed to be an arithmetic series in the shape, and then s minimum is equal to s, then if this is multiplied by a positive number, so the new transformed x would be x dash, which is equal to gamma times x, then here s dash minimum is equal to s dash, we just simply assume. Then we conclude the following results, in which s dash is equal to gamma times s, regardless of the size of the data. Hopefully you have learned this new dimension of this minimum sum, and thank you.